first things first, there's a little bit of machinery outside of my room, so you might hear it, a low rumbling. Okay, that's all. Now let's jump into the exercise. Now the exercise, before we're even talking about part A, part B, part C, part D, part E, part F, we will first establish that this is a sequences problem. And ladies and gentlemen, I need you to understand the following. When you face a sequences problem, there are two main types of sequences that you can face. One of them is what we will call the arithmetic sequence, arithmetic, and the other one is the one that we will call the geometric. Now, for the arithmetic, I need you to associate it to adding and subtracting, while for the geometric, I need you to associate it to the multiplying with dividing, okay? For arithmetic, we talk about a common difference. So however much you add or subtract by will be D, while for geometric, we have a common, what we call ratio. So you multiply or divide by a so-called R. Okay, so that's the first thing we need to talk about. An arithmetic sequence is adding or subtracting. A geometric sequence is multiplying or dividing. If you still have no idea what I'm talking about, well, first of all, pay a little bit more attention in class. And second of all, an example of an arithmetic could be maybe something like, I don't know, you go from 2 to 4 to 6 to 8. And so here, clearly, you are doing plus 2, plus 2, plus 2. And just to talk a little bit about the sort of language and vocabulary that can show up for this exercise, this first one is what we will call U1. U1 as in like the first term, okay? This guy, the 4, is going to be U2. This guy is going to be U3. This guy is going to be U4. Because in your arithmetic sequence, this is your first number that shows up in your pattern, right? So this is U1, this is U2, this is U3, this is U4. You can think about it as this is my first number, my second number, my third number, my fourth number. By how much are you increasing? By plus 2 each time. So up here, you would have a D equals of 2. An example of a geometric sequence, as I said, it's multiplying or dividing. So maybe you start with the same U1, okay, you also start with 2, and you also end up with 4, but here you end up with 8, you end up with 16. And so immediately you say, this can't be just adding, because if it was adding, here you have a plus 2, but here you have a plus 4. And so the important thing about the arithmetic sequences is that you always add or subtract by the same common difference, okay? If you have a common difference that is changing over time, then you're probably dealing with a geometric sequence, which would actually make more sense, because if over here you have times 2 instead of plus 2, it makes more sense. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And so the common ratio here would be R equals 2. And once again, this would be my first term. This would be my second term. This would be my third term, and this would be my fourth term, okay? So that is pretty much all we need to know, at least from an intuitive standpoint, of what sequences actually are. So after that relatively short introduction, I'd say, now we can jump into number 2. Number 2 for paper 2, we have that Dinah makes pendulums to sell at a market. That is actually really cool. She plans to make 10 pendulums when on the first day, and on each subsequent day, make 6 more than she did the day before. So she will be making 6 more than what she did the day before. And so for part A, we need to calculate the number of pendulums she would make on the 12th day. So the first thing we need to identify is that, this is clearly a sequences problem, because you have an initial amount, then you have, like, the first day she has 10, and then the next couple days she has more and more and more. So immediately you should be thinking sequences. Now the next challenge is identifying, is it an arithmetic sequence or is it a geometric sequence? And as this guy online told you, Not that you should trust guys online, but at least this guy for math, you definitely can. Okay. It's an arithmetic sequence because here it says that Dinah will make 6 more than the day before. It doesn't mean, it's not saying she will make 30% more or that she will double it or triple it. No, it's saying she will always do simply 6 more. And so here you can immediately say, okay, so D has to equal 6. And on the first day, she's making 10. So my first number, my U1, has to be 10. Okay, that is all I know right now. And for part A, you need to calculate the number of pendulums she would make on the 12th day. And so here what they're asking for, technically, by asking the 12th day thing, they're not asking for the total like it shows up later. They're asking simply how many she made on the 12th day. So they're asking only for U12. That is what they're trying to find. Okay, so this is the context. You have U1 equals 10. You have D equals 6. And they're asking for U12. So how the heck do you do that? Well, you could write it out until you reach U12, but that's not particularly exciting. So go ahead, open up your formula booklet, and let's have fun with what they call math. And yes, that's ironic. So over here in the formula booklet, it's very important that you get familiar with it. See? I talk about this all the time in my videos, and the main message is the following. It's no use to have the formula booklet if you don't know what's in it. Because the day of the test, the moment you recognize this is a sequences problem, you should be thinking in your brain immediately, sequences, I know I have a couple formulas in the formula booklet. You don't know them by memory, you're not sure exactly what they do, but you should know that they're in there. And so you read sequences, you recognize that it's sequences, and boom, you're opening up the formula booklet, boom, you're going to the sequences, and here they are. And here, if you studied enough with the formula booklet with you while you do homework, while you do tests at school, because it should be allowed, in my opinion. I mean, you use the formula booklet the day of the AB test, so why not during every other test, right? And so get familiar with it, use it, learn it, love it. Once you get familiar with it, you will start recognizing, okay, so for sequences, I have 2 boxes, right? The box on top is for the arithmetic sequence, while the box on the bottom is for the geometric sequence. And as you can see, they both have like the same sort of type of formula. The one up top is for the nth term, while the one on the bottom for both is going to be the sum of n terms. Okay, so basically one of them is for the sum, the other one is for a specific term that you're looking for, right? And over here, you are looking for a specific term. You're only looking for term U12. And so, okay, so in the formula booklet, I know right now from the exercise, yeah, we'll do it over here, it's fine. So I know from the exercise from part A that U1 is 10, that D is 6, and that I'm trying to find U15 it was? U12, sorry. U12. That's what I'm trying to find, right? And so because I'm looking for the nth term, I need to be using the formula up top, of course. That's going to be my first option. If that doesn't work, we probably need to get creative using something else. But right now, it works if you just go to your first option. So your first option, using the formula up top for the nth term. And as you can see, what does it ask for? Well, look at that, how convenient. It asks for U1, which you have. It asks for N, which you technically have, and I'll explain in a moment how. And you have D from right here. So how the heck do you have UN on the one hand, and how the heck do you have N? This is the thing about having the formula booklet and being familiar with it, because that right there, understanding that you do have UN, is really simply understanding the formula, see? So don't fall into the trap of, oh, I have the formula booklet, so like I'm good to go. No. You gotta know how it works. You gotta know the formulas behind it. You gotta figure out these sort of nitty bitty details, okay? Point is, because you're looking for U12, technically in this formula, you would be plugging U12 right here. I mean, we can all agree with that. So if you go ahead and plug in U12 right here, U1 plus parentheses n minus 1 times d, well, notice this n that I'm putting now in red is the same n that's right there. It's literally the same n. And so if you put U12 on this end, you are immediately establishing that you're looking or using the formula with an n equals 12. So boom, you erase this, boom, you put a 12, boom, you plug in U1, boom, you plug in D, and voila, there is your formula for U12. And so the main message, and this is something that will show up all along this exercise, is that you define what n is. Okay, the nth term, you define n. And wherever you define n, you gotta change it all over. Okay, and this will happen on all my equations. This n here will be that n there, that n here, this one, this one, this one. Okay, it's very important that you're consistent with, okay, whatever your n is, it's gonna be your n all over the place. A lot of people get confused and leave un as un. No, you establish n. If you're looking for U12, immediately that should be telling you that your n will be 12 for the formula. Okay, so establish that, understand it, and you're gonna be good to go. Yeah, so U12 is this whole thing. So clearly I gotta do 10 plus 12 minus 1, 11 times 6. So U12 has to be 10 plus 66. And with some quick maths, U12 for part A has to be 76. Just so that you all believe me and trust this guy on the internet, at least for math, here you have that 76 right there. Method point for using the appropriate formula. Cool. Yeah, so part A, let me just put it over here. So for part A, we have that U12 ended up being 76. Let me put it in blue, just so that we remember that this is the answer. Then they tell us that she plans to make pendulums for a total. This is such an important buzzword that they even put it in bold. A total of 15 days in preparation for going to the market. And so for part B, of course, we need to calculate the total, once again, the total number of pendulums she would have available at the market. In other words, Dinah will make pendulums for 15 days in a row. And they're asking for the total amount of pendulums she creates at the end of those 15 days. And so, a lot of you might already be thinking, well, I can write out the U1, U2, U3, U4 until U15, add them all up, and I'm good to go. And I'd say, yes, you can do that, but it's a massive waste of time. And this is why you gotta be familiar with the formula booklet, because as I mentioned earlier, focus on what I have in pink. Both for arithmetic and for geometric, you have formulas for the sum of n terms. And so if in this context for part B, we're looking for the sum of the total pendulums after 15 days, clearly I gotta be using the formulas down here. All right, and here goes another important disclaimer that I have to go over. All right, so let me raise a little bit of this to make some more space. This is the following disclaimer. In the formula booklet, oftentimes you're going to encounter that for the sum of, for example, this formula, see? For the sum of n terms of an arithmetic sequence, technically you have two. You have the one over here, and you have the one over there. So what the heck? What's happening? Even for geometric, you have the one over here, and you have the one over there. All right, what's happening here? Why do they do that? Well, for arithmetic, what you need to remember, and not by heart, not by memory, but you do have to remember or open the formula booklet and recognize, there's two formulas. Something was happening here. See? I really need you to focus on the following. When this happens to you in any formula in the formula booklet, okay, really establish piece by piece, this first formula, what does it ask for? So this first formula, you need n, for example. You need u1. You need d. While the second formula, what does it ask for? You need n as well. You need u1 and you need un. And so they have some stuff that is pretty much in common, the n and the u1, clearly. But the main difference between both formulas is that one of them asks for d and the other one asks for un. And so that's the kind of stuff that you need to be aware of using the formula booklet so that it doesn't get overwhelming, so that you don't get confused. Get familiar with the formula booklet. That's my main message that I'm going to give you in every single one of my videos, because it is absolutely important and essential for you to do well in this exam. So you have these two formulas. Clearly you got to use one or the other. See? Now, before jumping back to the exercise, let's first talk about the two formulas down at the bottom. If you do the same sort of, I don't know, I don't want to say procedure, but the same approach, yeah? If you do the same approach over here, what does this first formula ask for? It asks for u1, it asks for r, it asks for n. And the one on the right is also asking for u1, is also asking for r, is also asking for n. So this one down here is a little bit more troll. They're literally asking for the same three things. So you can use either one of them and both of them work. Okay? For the sum of n terms of a geometric sequence, it does not matter which equation you use. I'm not sure why they put 2. Whatever. They both work. Okay, that's what I need you to understand. They both work because they both use the same amount of variables. So there will never be a scenario where you use one over the other. That's what I'm trying to tell you. Well, up here for arithmetic, there are scenarios where you use one over the other, because the main difference is having d or having un. And so over here, if we come back to reality for part B, well, what do you have, right? We do have u1 from earlier. We do have d, and we're looking for the sum of 15 days. And so technically, for using the equation on the right, I would need to have u15, which I do not have. I could find it out using this formula here, but that sounds like extra work. And who likes to do extra work? Mostly nobody. See? So from here, instead of using the formula on the right, which asks for un, I'll use the formula on the left, which only asks for d, which I do already have. Okay? So, lo and behold, for part B, we will be using the equation on the left. So for the equation on the left, I'm going to put s of 15. So immediately putting s of 15 here, let's recall that I'm saying that n is 15. So you're plugging in 15 for all of these guys in red. ¿Vale? So that's the other thing. You are already saying that n equals 15 in this context. So n is 15. U1, you have it from earlier, it's 10. And d is 6 from earlier as well. ¿Vale? So plugging in these three things into the formula on the left, you have s of 15 equals 15 divided by 2 times 2 times u1. U1 we said was 10. Plus parentheses 15 minus 1, close parentheses, times d. D is 6. Yeah, so if you follow the procedure a little bit, you can actually just plug all of this into your calculator, to be honest. Yeah, why don't we just plug it all into our calculator? Talking about doing less extra work. So this fraction here, we can do alpha y equals, press the first one to do a fraction, so 15 divided by 2. Be consistent with your parentheses. Here you have 2 times 10. Another parentheses, plus the other parentheses, which is 15 minus 1. Close times 6. And then close. See? All right, I think it looks the same as what I plugged in over there. I press enter. Error with the syntax. Okay. I know why this is happening. See, and I'm glad this showed up on my video because it's probably happening to more than one of you. So what's happening here is that I put an extra parentheses there. Actually, no, I missed. Did I miss? No, yeah, I put an extra parentheses here at the end. Now we're okay, ¿cierto? Now we have a bunch of pairs of parentheses. Before I had an odd number of parentheses. Now I can press enter. Now it works. So S of 15 has to be 780. So that means after 15 days, Dinah has created 780 pendulums. That is a lot of work. See, there's the 780 method point for using the arithmetic sequences sum formula. All right, cool. So that's for part B. So for part B, we can write that S of 15 ended up being 780. Let me put it in blue so that we recall that this was the answer. We keep on reading and we have that Dinah would like to have, important, at least 1,000 pendulums available to sell at the market and therefore decides to increase her production. She still plans to make 10 pendulums on the first day. So we still have, what this is telling you is that you still have that U1 is 10. But on each subsequent day, she will make X more than what she did the day before. So instead of making 6 more, now you have a new D. So D, well, it says X more, so D equals X. See, so D is something that you don't have anymore, okay? And so for part C, we have that given that she will still make pendulums for a total of 15 days, so it's still for a total of 15 days. Calculate the minimum integer value of X required for her to reach her target. So there's a couple of things happening here. And this is where you have to have a greater understanding of the formulas, see? So on the one hand, we're still making a sum formula because we're still talking about the total amount she wants for 15 days. Now, here you might be working a little bit backwards because as I mentioned earlier, technically the difference between these two formulas is that one of them has D, the other one has UN. But also, if you get really, really creative with it, and sometimes working backwards, ¿cierto? Sometimes instead of plugging X and getting a Y, you gotta plug in a Y and get an X. And for these formulas, the same thing is happening, ¿cierto? Technically, the other thing you can be plugging in here is literally S of N. And yes, it's something that they both share because they're both, like sum formulas. But technically, there is a scenario where you plug in S of N, you plug in N, U1, and etc., and that helps you find D. So let's see how that happens. So, and how I figured that out, right? So it's very important that you highlight these buzzwords and go figuring out which formulas which variables you have and which ones you don't in order to see which formula you use. Because you're going to be using a sum formula. We're still talking about sum. We're still talking about an arithmetic sequence. So all good in that sense. But what you need to establish is, okay, do you have U1? Do you have N? Do you have D? Do you have UN? Do you have U1? Like, what's happening, ¿cierto? So on the one hand, they want you to find the minimum integer value for X. Okay, this is the most important part. They want you to calculate the minimum integer value of X. Now, X is your new D, okay? So clearly you need to find D. Yeah, so we're probably using the equation on the left. So can I plug in N and U1 and S of N? If you plug in these three things, you can find X. If you're a little bit confused by that, just follow the process for now. See, identify you're gonna use one of these formulas, write out the variables you need, and write out the variables you have. So D equals X, you're trying to find X. Do you have, for example, U1, right? Well, they still tell you that you make 10 pendulums on the first day, so U1 is still going to be 10. On the other hand, we're still talking about a total of 15 days, so N is also going to be 15. Bada bim, bada boom. And last but not least, they tell you that Dinah would like to have at least 1,000 pendulums available. So, if she needs to have at least 1,000 pendulums available, then S of n has to be at least 1,000. Now, when we talk about at least, technically, I guess I would say S of n has to be greater than or equal to 1,000, okay? If I were to get a little more technical, that's what I would say. But at least 1,000 pendulums available to sell means that S of n, we're going to leave it as, well, at least the 1,000. So, boom. Once you establish that, you realize you can use the equation on the left, and that will help you find D. So if you plug in everything on the equation on the left, yeah, so this would be now for part C. So for part C, if you plug in all of this stuff that I'm putting right here in, I don't know, red, ¿cierto? If you plug all of this into that equation, what you end up with is 1,000. And you need, we'll put it equals. So equals 15 divided by 2, because n is 15, parentheses 2 times u1, which is 10, plus n, which we're calling 15, minus 1, times d, which is going to be x. So from here, this does look absolutely nasty. This does look terrible. There are a bunch of parentheses. There isn't 1,000 rolling around. But how many variables do you have? You only have x. So that means that you can reach x equals an actual number. So the main idea here is that you figured out a way to create a formula that only has the variable that you're looking for. And the big brain play, in my opinion, was realizing that you can plug in 1,000 for S of n. And so that is what I mean by use the formula booklet, be familiar with it, because that's the sort of tip or trick that you gotta know that you can use. Okay, and the only way to really train that is to be quick with the formula booklet, is to understand the formula booklet and really know how it works from beginning to end. Got it? So that means I can find the value for x from here. Getting it alone is a little bit annoying, but let's see what we can do. Okay, so what I imagine most people would do from here is that they would simplify everything piece by piece. So 15 divided by 2 is going to be 7.5. Parentheses 2 times 10 is 20, plus 14 minus 1 is 14. And this 14 won't be multiplying the x, so we will just leave it as 14x immediately, plus 14x. Now from here, you want to, there's more than one way, but what I imagine most people would do is multiply and distribute this. So if I do that first, I end up with 1,000 equals 7.5 times 20, 150, plus 14 times, that's 7.5, 105, 105x. So if you do minus 150 and then minus 150, you end up with 105x equaling 850. I'm pretty sure about my thought process, but let's be honest. The day of the test, you plug in everything into your calculator, so let's replicate that. 105x equals 850. Divide by 105, divide by 105. You end up with x being equal to 850 divided by 105, 8.09. So basically, in order for Dinah to reach 1,000 pendulums by day 15, this formula tells me that she needs to be, her common difference has to be 8.09. So if she creates around 8.09 pendulums, if her common difference is 8.09, so if each day she creates 8.09 more pendulums than the day before, she's going to reach 1,000 by day 15. But the issue is, can you make 0.09 of a pendulum? How does that work? That is why over here, they wanted you to answer, what I have in pink, to calculate the minimum integer value of x. So something I didn't talk about earlier, but I will now, is that an integer, ladies and gentlemen, this does show up a lot, so make sure you know it. An integer is essentially a whole number. And a whole number that can be negative, so -2, -1, 0, 1, 2. A whole number that can be negative or positive, but only whole numbers. That it? So, the minimum integer value of x, think about it this way. If you ended up with x equals 8.09, the common mistake is that people say, you're closer to 8, so my final answer is x equals 8. But if you take this equation, ¿cierto? If you take this equation right here, and you, instead of putting d equals 6, you put d equals 8, which would be rounding down, which is the common mistake, you end up with less than 1,000. And so the minimum integer value of 8.09, in order to still get at least 1,000, you have to round it actually up. So that's a little bit of a context trap, a pretty common thing that happens. That x gotta equal 9 in this case. Another common example, just in case you run into it, is like, I don't know, Michael is painting a fence. And you're trying to figure out how many days Michael takes to, how many days Michael takes to paint that fence. Okay, so how many days does Michael take to paint that fence? And your answer ends up being, I don't know, 5.2 days, right? And so if Michael goes to his boss and says, yo, you gotta pay me for 5 days, that's not exactly accurate, because on the 6th day, he worked for 0.2 of that day. So if he worked for 5.2 days, you can't round it down to 5. You're not getting paid for that other day, ¿cierto? So you gotta round it up to 6. Fair is fair. He still showed up at 8 a.m. to work, ¿cierto? So in that sense, for context, a lot of times you end up rounding maybe up in the direction that maybe doesn't make too much sense for you, because how the heck do you round from 8 to 9 here? From a mathematical standpoint, you don't have too many arguments, but context-wise, it makes a lot of sense. If Dinah still wants to reach 1,000 pendulums, she will have to do a common difference of 9. She's not gonna reach it with a common difference of 8. And if you really want to check your work, just plug in a 9 right here, and you will see that you have over 1,000. All right. So I think I can't leave it more clear than that. I'm just explaining why they put that thing in pink over here. And it's pretty common for you to answer like that for a context questions and stuff like that. See? So for part C, we will be saying that we ended up with an x equals of 8.09, but rounding it to the minimum possible integer value, we have to say that x equals 9. Okay? So this right here will, I cannot put it in blue like I want to. Let me try one more time. So maybe from here. Yeah. This is my answer for part C. And if you check the answer key, it literally says, you gotta prove that you understand that although you got 8.09, you gotta end up with x equals 9. Dale? So 1 method point for, once again, using the formula, get to know the formula booklet well, and then 2 answer points for understanding that you gotta round it up. See? 1 answer point for what you got from the formula, another answer point because of the context and the thing that I put in pink. So very important what they put in pink. It's literally worth a whole point. All right, let's keep going. So from here, now we have that Dinah tests one of her pendulums. She releases the ball at the end of the pendulum to swing freely, and the point at which she releases it is shown as the initial position on the left side of the following diagram. So the initial position, clearly, as you can see, is right there. Yeah. Dinah begins recording the distances traveled by the ball after it has reached the extreme position. So the U1 that they're putting right here is there, ¿cierto? So notice, this swing is U1. This swing is U2. This swing is U3. This swing right here is not U1, okay? Have that in mind, it might become relevant, ¿vale? So U1 is 17.1, U2 is 16.245, U3, we don't have it yet, ¿vale? But those are my first three swings. So again, context-wise, a lot of you are probably thinking in your brain, isn't this technically your first swing? And although I completely agree with you, nobody cares. The first swing is whatever the exercise is telling you. They're telling you that the first swing is when it comes back after reaching the extreme position, which is this right here. So after reaching this extreme position, your first, second, and third are every back and forth from there. Yeah. They tell us that on each successive swing, the distance that the ball traveled was, will you look at that, 95% of its previous distance. During the first swing, so first swing that Dinah recorded, the ball traveled a distance of 17.1, and during the second swing that was recorded, it traveled a distance of 16.245. So before even jumping into parts D, E, and F, we can already say if we're talking about 95%, well, this is clearly not like D equals 2 or D equals, I don't know, -3. We're talking about 95%. And so think about it this way. If we're not talking about +2, +3, +4, or -2, -7, -6, then it has to be a geometric sequence. So that's the first thing we can establish. It's a geometric sequence. Now, how does the geometric sequence work? Well, I did give a quick sort of trailer earlier. It's multiply or divide. You talk about a common ratio, and the example that I gave was R equals 2. R equals 2. Now, think about it this way. If R were equal to 1, if R were equal to 1, well, what would happen? If R were equal to 1, it would be a little bit troll, but let's understand what happens. So if R were equal to 1, you do times 1 each time. So that means you end up with 2, 2, 2. So R equals 1 doesn't make much sense, ¿vale? However, if you change it just a little bit from around 1, ¿cierto? So if you change it from R equals 1 to R equals 1.05, well, what happens now? So each time you're multiplying by 1.05, and so what happens then? ¿Cierto? Well, let's actually fill it in and see what happens. So this 2, this first term is 2, ¿cierto? So 2 times 1.05. The second term ends up as 2.1. And then the third term, so again times 1.05, ends up as 2.205. And then if I multiply again by 1.05, you end up with 2.31. All right, you guys, here's the main idea I'm trying to show you. So if you multiply by R equals 1, nothing happens. But if you multiply by R equals 1.05, what's happening is actually a 5% increase. So this guy's talking about this because he wants to talk about percentages. Yes, as you've probably seen in probability, 1 is 100%. 0.5 is 50%, and 0.05 is 5%. And so if in this exercise they are talking about that each previous distance, thing, swing, whatever, is 95%, then they're saying that R has to be 0.95. So that's the first big thing I will mention. If it's 95% of its previous distance, R equals 95. Which is much different than if they say 95 less. Okay, so notice, if they were saying 95 less, then R would be 1 minus 0.95. R would be 0.05. So that would be 95 less. It's a huge decay, okay? Over here, technically your decay is simply 5%. So you end up with R equals 0.95 because you do 1 minus 0.05. So the decay is pretty small. It's only 5%. Don't confuse that. See? It's pretty common for people to say, 95% less. So they do 1 minus 0.95. You end up with 0.05. And this is a huge decay for an R value. ¿Cierto? For your R common ratio, I mean. ¿Dale? Here they're saying it's 95% of its previous distance. So the decay is only 5%. R equals 0.95. Very important difference. Watch the language. It is essential in this exercise. So R equals 0.95. And they tell us that the first swing, which is right here, so the first swing, what we will call U1, is 17.1. ¿Cierto? And then for some reason, maybe it becomes relevant, maybe not. They also tell us that U2 is 16.245. So this is all we have. You have U1, you have U2, you have R. So let me put in maybe pink what we have. You have R, you have U1, you have U2. Enough blah blah, let's get into it. For part D, you need to calculate the distance that the ball traveled during the 5th recorded swing. So this is awfully similar to the stuff that they're asking up here in terms of procedure. For part D, much like part A, they're asking for the distance for the 5th recorded swing. They're not asking for the sum of the distance and the total of this or that. They're only asking for U5. They're only asking for U5. And so they're asking for the nth term. They're asking for the 5th term. So here, we can use the nth term of the geometric sequence, which is right here. Now, clearly, I have run out of space over there, so let me bring it over here. So for part D, we have that the formula is UN equals U1 times R to the power of n minus 1. All right, cool. So we have R, we have U1, we have U2. You're trying to find U5. So the moment that you plug in U5 over here, well, clearly this n right there is the same n that's right here. So the moment you plug in U5, that means you have U5 equals U1, which is 17.1, times R, which we know is 0.95. And then this n is the same as that n here. We established that n equals 5. And if we plug in 5 there in red, we got to plug in it on the exponent as well for that n up here. See? So you define n, follow through and plug it in for everything. There is my formula. Let's plug it into the calculator because no one knows how to do that by hand. And if you did, well, I highly suggest you use the calculator anyways. Plug all of this into your calculator and smile because you just got some free 3 points. So U5 gotta be 13.928. 13.928. If you wanted to do significant figures, you would count 1, 2, 3. Do you round it up or keep it the same? You round it up. So significant figures, if you'd like, you can leave it as U5 equals 13.9. Here's the answer so that you keep on trusting me. There's the method point of using the formula. Bada bing, bada boom. That is for part D. For part E, you need to calculate the total distance that the ball traveled during the first 16 recorded swings. So now we're talking about total distance. Again, same procedure as part B. Now we're talking about the sum of the total distance. So clearly, they're looking for S of n, right? Now, they're talking about the first 16 recorded swings. So technically, that helps me establish that they're looking for S of 16. So for part E, my formula for sum of distance, my formula for the sum of n terms of a geometric sequence, there were 2 formulas I can use. And much like I established earlier, it doesn't matter which one you use because they're asking for the exact same stuff. Okay, they both ask for U1, R, and N. They both ask for U1, R, and N. So you can use either or, it doesn't matter. Just to be a rebel, I'm gonna use the one on the right. Okay, whatever, I'm gonna use the one on the right. And so for part E, yeah, we can do it over here, that's fine. So for part E, our formula is S of n equals U1 parentheses 1 minus r to the power of n divided by 1 minus r. Dale? Quick disclaimer, r cannot equal 1. Well, because as I showed earlier, it would be a geometric sequence that's a little bit troll, that's not really changing. But more importantly, it's because your denominator would end up as 0. You can never divide by 0. Okay, so that is one small, not too important detail, but just so that you feel calm. Why can r not equal 1? Because your denominator would equal 0, and you cannot divide by 0, no matter how hard you try. Okay, so this is my formula that I will be using. What do I need to plug in? You need to plug in S of n, or maybe find S of n, ¿cierto? I don't know, whatever, ¿cierto? Or these are the things, let's think about it this way. These are the things you can plug in. You can plug in S of n, you can plug in U1, you can plug in r, and you can plug in n. And so right now for part E, because we're looking about, I cannot English today. Because we're trying to find the total distance that the ball traveled in the first 16 swings, that means that n has to be 16. That means that r is still the same r as before, 0.95, and that u1, it's still the first swing, u1 is still 17.1. And so S of n is actually what we're going to be finding. So if we plug all of this into the formula, you end up with S of 16, because n is 16, so this n will go here, and it will go there. So S of 16 equals U1, which is 17.1, parentheses 1 minus R, which is 0.95, this is a 9, to the power of n, which is 16. Close parentheses, divide by 1 minus R, which is 0.95. So put all of that into your calculator because might as well keep it friendly. Alpha y equals, then the first one for a fraction, we can put 17.1, parentheses 1 minus 0.95, and only the 0.95 is to the power of 16. Cierto? Small but important detail. So only the 0.95 is to the power of 16. You close the parentheses, and in the denominator you do 1 minus 0.95. Go ahead and press enter. S of 16 is whatever that is. So S of 16 equals 191.4766. 0.4766. So if you count in terms of significant figures, do you round it up or keep it the same? You can keep it the same. So S of 16, you can leave it as 191 if you'd like. Either of these work, just so that you keep believing me. There it is, there it is. Don't forget your units. Whoops, this is all in centimeters. So my answers up until now, I forgot to put them in blue, but here I go. For part D, it's this or this. For part E, it's this or this. Okay? Yeah. Last but not least, for part F, we need to calculate the distance that the ball traveled before Dinah started recording. So this one is a little bit more big brain than the other ones. Okay? This one is a little bit more creative, and you gotta understand exactly what it's asking for. So the distance that the ball traveled before Dinah started recording. So the big thing here is that they're telling you before Dinah started recording. And so when did Dinah start recording? She started recording after it reached the extreme position. So this first line here, this first swing, is not recorded. And the ones that were recorded are U1, U2, U3, which is every back and forth that happens after that. ¿Cierto? And so the one that they're trying to find for part, whoops, went a little far. For part F is the distance that the ball traveled before Dinah started recording. So you can think about it as like the actual initial swing. I know that context-wise, we've been treating U1 as sort of like, quote unquote, the second swing, ¿cierto? Or the first one after reaching the extreme position. But right now, we need to find the distance traveled by this not recorded swing. And so the cool thing about geometric sequences is that, think about it this way, ¿cierto? So you have U1, and U2. So you have U1 and U2. You know that U1 is 17.1. You know that U2 is 16.245. And you know from the exercise that R is 0.95. And so the big concept that we need to understand here is that much how I showed it visually up there, if you write it out as, for example, oh, your U1 is 17.1 and your U2 is 16.245, well, you know that your R is 0.95, so you know that going in this direction, you have a times 0.95. And you can actually double check this. Okay, so let me make a little bit of space. Technically, this is your U1. U1 is 17.1. 17.1. U2 is 16.245. And you know that U1 times your R has to give you U2. And you can actually check that. So 17.1 times 16.245. Well, whoops, I'm trolling. I'm trolling. Hold up. 17.1 times your common ratio, so 17.1 times 0.95 should be giving you 16.245. And so that's if you multiply, ¿cierto? And now, and let me check this, but I'm pretty sure it works. It does work. Okay, perfect. So think about it this way. For the arithmetic one, whoops, this is a very important concept to grasp. So I'm going to explain it for a second. That it? For the arithmetic one, if you wanted to go, for example, from U1 to U2, you would do +2. But if you wanted to go from U2 to U1, you would actually be doing -2. So if you want to work backwards, well, if forwards you did plus, for backwards you will do minus. Makes sense, right? Well, for geometric, it's no difference. If we're going forwards, you did times 0.95. If you want to go backwards, you just gotta divide by 0.95. Bada bim, bada boom. So this guy online, when he told you earlier, you need to associate arithmetic to plus and minus and geometric for times and dividing. It helps you to do these sort of connections. For moving forward in arithmetic, for this context at least with a positive D, you do +2, +2, +2. And to work backwards, you can do -2, -2, -2. For the geometric in this case, if you're multiplying by 1.05, to work backwards, you can divide by 1.05. And so it's no different over here. So for U1 to U2, you multiply by 0.95. And from U2 to U1, just so you believe me, and it's right here, you do 16.245 divided by 0.95, and you end up with U1. And so if you do that one more time, divide one more time by 0.95, you end up with the mythical U0. And so 17.1 divided by 0.95, so going backwards one more time to go from U2 to U1 to U0, U0 is 18. And that is your argument, ladies and gentlemen, for the not recorded swing to be a distance of 18 centimeters. So for part F, you would say that that U0 is 18 centimeters. Your argument can simply be that U0 has to be U1 divided by R, quite literally. So U0 has to be 17.1 divided by 0.95. U0 gave you 18. And this right here is what we did right there. Okay? If you check the formula, the mark scheme over here, you're going to figure out that there's more than one way. There's a ton of different ways. And this is the way that we did. Okay? This is the way that we did it. That's what I meant to say. Dale? Your answer is 18. Put the units centimeters. That is for part F. Ladies and gentlemen, this was a thorough exercise of sequences. I hope you learned more than one thing. And more than anything, I hope it helped. So that being said, I'll see you around. Take it easy.